Thanks for being here. So I'm Mike Horgan. We'll be doing this. I'll be doing this workshop with Jennifer Rennick. We do all of this stuff intensely collaboratively. It's pretty awesome to be able to work with Jennifer doing workshops like this. I'm a licensed builder in California. I was licensed in Massachusetts. I was licensed in both states. Not going to build in snow anymore, so we'll let the Massachusetts one run out. And I'm a certified Passive House International certified Passive House designer. Jennifer is an architect, building scientist, certified energy analyst, just all around genius and amazing human. So thanks for being here and letting us go through this with you.
That's why I like Mike to do the intros.
So today we are talking about heat pump water heaters for energy code compliance. We teach a bunch of workshops. This is one that's usually well attended. I think our goal is that you will, if you can't take something from this and put it into your practice immediately, you will at least be able to take this workshop and tell people that you attended it, you heard about these things. I'm admitting people in as I'm talking. And maybe further the conversation with some of the things that we'll talk about, and hopefully you'll further the conversation with us. So something we like to point out is that we used to do these workshops in person. And when we did that, we were able to read the room and kind of gauge, people's reactions, see their faces. And Jennifer and I really appreciate the conversation aspect of a learning environment. So we can't quite do that right now, but we do encourage asking questions during the workshop. You can wait till the end, of course, but sometimes waiting till slide 40 to ask a question about slide 15, things get lost in translation. So we encourage asking questions as we go along through the workshop. So heat pump hot water heaters, what are they? Where can they be used? We'll go over some design considerations because there are some in terms of placement. Can they be used to replace existing gas water heaters? Short answer, yes, not exactly easy. How do we find them? Where can we find them? How do we show compliance? These are the learning objectives for, this is for AIA, correct, Jennifer?
Yes.
If you're looking for learning objectives? Okay.
Yes.
Okay, so we're going to get right into it so that we keep most of the presentation down under the hour, and we leave plenty of room if you do have questions, and we usually stick around for a bit afterwards too. So kind of the common joke to start off talking about, heat pumps is, who has a heat pump in their house already? Have you ever seen one? And the answer is all of us. And we've all seen them, and we use them every single day throughout our lives, and we have been forever. So a heat pump is basically a refrigerator. It's a refrigeration system, cost-effective, very efficient, very easy to install. We have friends in town, not builders, I would say not even mechanical, and are installing them on their own on their houses. So it's quite easy to do in the field. If you're in the industry, I have found that the trades find it very easy to install. No flues, no gas, no combustion, no venting. It's pretty remarkable. It makes for a really clean installation, a very streamlined system. So here's a quick little video. This is for our Rheem rep who's hanging out with us today.
Introducing the new Rheem Hybrid Electric Water Heater. With a uniform energy factor of 3.55 to 3.70, this is the smartest and most efficient water heater on the market today. It can save homeowners up to $4,750 in energy costs, and it's the quietest hybrid on the market at 49 decibels. Plus, the Rheem Hybrid is compatible with the EcoNet smart monitoring system, offering Wi-Fi connected control both at home and away. Here's how it works. A fan pulls air through the upper enclosure of the heat pump. The air passes through a filter to remove any debris or dust. Heat in the air is absorbed by the eco-friendly refrigerant inside the evaporator coil, and cool, dehumidified air is exhausted. Refrigerant is pumped by a compressor through the refrigerant system. The compressor increases the temperature of the refrigerant, which is delivered to the condenser. The condenser tubing is wrapped around the water heater tank where heat is transferred from the refrigerant to the water. All functions are controlled simultaneously by an advanced control. In energy saver mode, the heat pump and electric heat operation is utilized to optimize efficiency based on hot water use. In high demand mode, the heat pump and electric heat operation is utilized to optimize hot water delivery. In electric mode, the heat pump is disabled and the appliance operates like a standard electric water heater. In heat pump mode, the water is heated exclusively by the heat pump operation. In vacation mode, the water heater maintains 65-degree water for up to 28 days. The condensate drain routes the condensation created during the water heating process away from the unit. The built-in condensate management system will shut down the compressor if it senses water outside. This helps prevent damage and will send an alert if the condensate drain needs to be cleaned. A leak detection cable is also included. If water is detected in the drain pan, the unit emits an audible alarm and sends an alert to the homeowner's phone through the EcoNet app, which can help save up to $4,000 in costly water damage repairs. The electric elements are accessible on the front of the unit in an upper and lower location. The Rheem hybrid water heater installs as easily as a standard electric water heater. It also provides more hot water than most electric units and delivers it faster. The newest Rheem hybrid electric water heaters. Savings, peace of mind, and convenience from the start.
All right, so now we've basically just told all of you that all the information you need to know is on YouTube. So there's, if you don't want to tune out for the next hour and just browse YouTube, there you go.
What about code? Code, Mike? I got so much stuff on the Title 24 Energy Code.
So that was just the example from Rheem. There are different brands on the market. In the US, we essentially have 5 basic brands: Bradford White, Rheem, Stiebel Eltron, A.O. Smith, and Sandin. You'll notice that the Sandin is a little bit different than the others. We're going to talk about the different types of systems. I guess we should point out here too that we're not going to talk about how heat pumps work. We have a different workshop kind of devoted to how heat pumps physically and mechanically work. We've kind of assumed that most every one of us here understands what a heat pump is and essentially how it works. So we're not going to dive too far into the mechanical aspects. So these are our 5 available systems in the US. I have found no trouble getting any of these pretty readily available, apart from typical shipping delays right now, which could be anywhere from 1 week to 10 months. But on the average, they're pretty readily available. So.
Okay, so the reason we're hitting on hot water today, and the reason the state of California is really making a big deal to look at heat pumps and promote heat pumps for heating hot water, is California is trying to reduce the carbon footprint. We're trying to reduce the amount of fossil fuels that we burn because there's better use for our limited oil products. There's higher, better use than just burning natural gas and burning fossil fuels for heat. There's other ways we can make heat. And water uses about 25% of the energy that your typical household would use. So in California, we regulate our energy through the Title 24 code in our buildings. Half of that regulated load goes to the hot water, the other half goes to space heating and cooling, and then a large portion, around 40–45%, actually goes to all our appliances, all our gadgets, everything that we plug in, and lighting and ancillary uses. So if we can reduce the energy use on hot water, it'll make a big difference in how California reaches our overall energy goals. And heat pump water heaters, they can be used in a number of applications. So single family and multifamily, we've got commercial applications, And yes, they can be used in alterations and replacement. So they can replace any kind of existing water heater you have now. Today, we're gonna dive into the code, but we're mostly gonna use the framework of residential single and multifamily applications as we talk about the code. We'll be doing other workshops later where we go into more of the other applications.
So as we showed just a couple slides ago, there are two types of heat pump hot water heaters on the American market today, available in the market today. I believe it's on the left on your screen is the integrated, what we call an integrated heat pump. And on the right is what we call a split heat pump hot water heater. Heat pump hot water heater, hot water heat pump, interchangeable. I'm currently using a split on a project that I'm building in town now. And we have a few people around town who are embracing these integrated hot water heat pumps and installing them mostly in renovations. So they're doing the replacements using integrated heat pumps. So in the integrated heat pump, that heat pump is actually physically on top of your storage tank. And then in the split system, it's essentially like a heat pump mini split type system. So you have two units, one indoor, which is just a holding tank, just the storage tank. So we're actually putting that inside a laundry room cabinet. So it'll look like it's, you know, part of the laundry room. And if you open that door, you'd say, wow, there's a water tank inside here. And you won't even know. And then the condenser is outside the house, located in another spot. Let's see. Lost the slide. So identifying these. So an integrated heat pump has that heat pump on the top. They have this integrated control panel, which is essentially an interface that's usually on the outside of the tank, physically on the outside of the tank. Inhale and exhaust vents. So you can put these integrated systems, you can locate this. We often recommend locating this in a garage, where a garage might benefit from some cool air being put into that garage. If it's not a conditioned, not part of your conditioned floor area, putting this heat pump there, the cold air that comes out of the heat pump will actually help cool the garage during summer months. Large storage tanks, they're available in multiple sizes. I know Sandon has like a 43, 83, and I think 119. I think Rheem is in the same realm of those. So they do come in variable size tanks. The integrated has the electrical connection next to the system, whereas the split system has the connection outside with the condenser, which is shown down here in that right-hand corner. So on the split system, the tank that's inside doesn't have any electrical to it. It is just the storage tank inside the house. So it's split, just like a mini split system would be, two parts, one in, one out. The storage tank stays inside. Your heat pump, compressor, condenser, your coils are outside the house. And then you just run water lines, PEX water lines, from the tank inside the house to the condenser, compressor. That term also gets changed around, even though there is a correct word for it, but and you just run the water lines to the condenser that's outside the house. So, neither of these systems have gas, so neither of these systems have venting that's required for gas. So that's been a real benefit. I know the experience I've had bringing trades in and teaching them how to put this system in a physical house, the general reaction has been, you know, giving them the manual and looking at the manual together, and then all the plumbers kind of going, that's it? Like, this is all we have to do? And you kind of look at it thinking, is that all we have to do? Did we make a mistake? And it actually is all you have to do. It's really pretty simple. Let's see. So differentiating from electric resistance, sorry, command center control is a little wonky. Electric resistance, it's obviously not a heat pump, no condensers outside, big storage tanks, only using electric resistance. So this is very similar to how heat pumps got a bad name in America in the previous decades. because they would use very high speeds to operate the fans that move air across fan coils. And then they would use large amounts of electric resistance to make up for the fact that the air or water wasn't becoming conditioned fast enough. And that pretty much, that put a really bad taste about heat pump technology in the minds of most Americans. Whereas a lot of the rest of the world kind of kept moving forward and progressing, and now we're catching up to what they've been doing in Japan and China and New Zealand, Australia, and South America. So if you have your gas system in your garage, you have to vent it to the outdoors. You'd have a large storage tank, a lot of mechanicals that you'd be working around. You still have your normal electrical connection next to your unit, which is very similar to the Rheem. This is not unlike how a Rheem would look if it's in a garage system and you wanted to duct it outdoors, or you could just not duct it and have it go right into the garage and keep it cooling. So the systems generally look the same if you're using the integrated heat pump system. Tankless. So these are your Navians that we're real familiar with and seems to be a go-to kind of system. There's a lot of nuances as to how it's become the go-to type of system. And it's worth asking questions, listening to clients and asking them why they want that system and comparing it to what they could get if they use a heat pump system. Oftentimes I find that people, clients think that there's no wait time with a tankless system, and in reality, most people who have them do have significant wait times. There are workarounds around that, but so obviously you don't have a storage tank mounted generally on the outside of homes here. Integrated control panel, and again you have your normal electrical connection next to the unit.
Okay. Let's say you have a client who is going to install one of those Norwitz or the Navion or the A.O. Smith, Rheem, any of them, on-demand gas unit. That's kind of the code baseline right now, along with the heat pumps. So let's say they choose that route. What's new to the 2019 code is a mandatory requirement that a dedicated 125 volt, 20 amp electrical receptacle has to be included with that install. And there has to be a conductor such that the branch circuit can be isolated and it can be set up so that a future 240 volt hot water heater, i.e. heat pump water heater, can be installed when that tankless unit is no longer functioning. The panel has to be labeled, and that receptacle has to be of the special type. So it's usually looks like the little picture I put there with the slot in it, or sometimes you just see it as a small, the parts coming down, one's small and one's big, but it has to be of the specific type that will accommodate the amperage and the voltage needed. Next slide. This is a great little diagram blueprint through the California Energy Commission. They just show a little more closely what the code requirement is about the spare wire, that fourth wire being labeled and capped, and how that would be connected to that outlet, and pointing out that it needs to be within 3 feet of either the gas water heater, which could be a water tank like it's shown, or the on-demand style that I showed in the previous slide. Okay, next slide. The condensate drain is another part of the requirement. And we saw in that Rheem video, and it's true for all heat pump technology, it condenses water out of the air. And that condensate needs a place to drain too. So even if you're installing a gas unit, you still have to provide a drainage area that's near that water heater, so that when you put in your future heat pump water heater, you'll automatically have a place for that condensate to go. And then the other part of those mandatory requirements are specific for gas, if you end up going with a gas water heater. Okay, next slide. Now, it's good to point out that the condensate from the heat pump water heaters is just the water from the air. It's really no different than if you have a cold beverage and enough humidity in the air that water, those water molecules will condense on the side of the glass, and it's just clean, pure water. And that same is what's going to come out of the heat pump water heater, which is different than condensate when you talk about that from gas appliances. It's not that type of condensate. So this is just plain water. So let's say you're doing a retrofit situation and you don't have a way to drain the condensate. They do make little tiny pumps like the picture on the left that you can hook up and set up and connect that and then pump that condensate to like a sink or another place where you're draining, maybe for your utility or laundry. It's possible to use that for retrofit. Okay, next.
Just to jump in, we're
Yeah,
actually we're gonna use that on a new build, because if you are building custom homes, you know that homeowners will show up on weekends and suddenly there are change orders. So we've actually switched the system. We were going to go with an integrated system in the beginning, and we had set up for that in the garage and had a drain built into the garage. And then after a little research from the homeowners, they wanted to, we encouraged the switch to a split system, and they decided it was a good idea after all. So we switched. So we're actually in new construction going to use this same pump system and tie it into our, since the tank will be in the laundry room, we'll tie it into the laundry drains. So we can use it in new construction too.
Okay, so, but let's say now your client says, okay, that's great. I have to put in the electrical anyway. I have to put in the drain line anyway. Well, dang it. Let's just go with the heat pump water heater. Now, what do I need to know? Okay, so as an architect, as a builder, what you need to as an engineer, you need to know that the tank that you choose, the water heating system's got to meet your minimum mandatory measures. Of course, there's design considerations. Some of those are in the code, but a lot of them are not. We're going to hit on the codified ones. And if you're going to do new construction or alterations, there's some options available for how you comply if you don't want to use the performance method. And we're going to show you real quick how you would document that on your Title 24 form. Right off the bat, I would think for the engineers and for the folks from the city, county, et cetera, obviously the equipment needs to comply with the mandatory measures. It needs to comply with the minimum uniform energy factor. They have to comply with Title 20 appliance efficiency, on and on. Luckily, okay, all the heat pump water heaters available in our area meet all these minimums. But as a resource, maybe for the architects or some of the homeowners, you can send them to a couple of websites where they can see a list of qualified products. And as an engineer, you may need to find your product on these lists. Mike's going to run through that real quick.
These are 2 links. I believe we can get these to you. Either the links can be put in the chat or we'll send these out afterwards. This is we had to Google this acronym last night. It took us about 10 minutes to find it. The Modernized Appliance Efficiency Database. So
it always takes a while because I have a hot link on my computer, and for the life of me, I couldn't remember what the M was standing for. It's kind of embarrassing, but whatever.
So the MAEDB is the Modernized Appliance Efficiency Database, and you can go to these and get all of the information that you need and compare systems you might be thinking about using through these two websites. And here is another one, which is kind of like an Amazon type system where you can marketplace.pg&e, you can pick a couple different systems and put them on one page and compare them to each other simultaneously as if you were buying new work boots and wanted to compare 3 models. So, so they do.
Sorry.
Yeah, no, I was just gonna say they make it pretty easy to compare.
Go back one slide real quick. On the Northwest Energy Efficiency Alliance website, the NEA website on the right, I want to point out one thing. They break the heat pump water heaters into different tiers. I'm mentioning it now because it comes back on the code section. There's something called a tier 1 heat pump water heater and a tier 3 heat pump water heater. The tier 3 are more energy efficient. It's important to know for some of the aspects, if your heat pump water heater you want to use lands on the tier 1 or the tier 3 list.
And that ties into a bit of what kind of work you'll be doing. It ties into whether it's ADUs, renovations, those tiers play a part in that. So. Okay,
so the all the heat pump water heaters, just like our other appliances, are going to have an energy guide label that looks similar to this. For those of you who are really, for the engineers online, now the heat pump water heaters have been kind of divided up into use bins so that now a heat water heater gets compared with the same kind of type of water heater, or I mean, same use as the other water heaters. So it's a little bit more apple to comparison. And now for those of you who are doing energy modeling, you're going to use the UEF typically and not what used to be an EF score. And I find that these labels can help me as an architect to talk about this to potential homeowners in terms of how much energy, how much cost they'll expect. Now, these costs are based on 12 cents a kilowatt hour. So for our area, you may have to double or triple that number. And that's how much cost typically would be expected for your clients. There's a number of design considerations for the integrated heat pump water heater. It's not super entailed, but there's just a few things you need to know that's different than putting in, say, an on-demand gas unit. Mike talked a little bit about the heat pump itself being on the top. So you have to allow for air inlet and air exhaust from the fan. And that requires usually that the appliance has 36 to 40 inches clear where that exhaust air can blow and not be impeded by a wall or other objects. And the place you locate it, like the garage, it needs ideally an operating temperature that's more than 45 and less than 90 degrees. They're about 50 decibels in sound, so that's like the sound of a refrigerator. And if you're going to put it in an enclosed room, you're going to need 750 to 1,000 cubic feet of volume, or use a duct kit. And like that little diagram on the right shows a duct kit application where you can pull in air from outside, put it through the unit, and exhaust it to the outside and keep it separate from your conditioned envelope. Okay.
And then if you
over the sanded, yeah.
If you are using the split system, which is what we're using here in town now, and there are a few of these actually around San Luis County that a few people have installed on residential homes. There's generally a 25 to 50 foot separation between the systems. So part of the change that occurred during a change order in putting the tank in a laundry room was making sure we didn't separate the outdoor condenser too far from the interior storage tank. So we had to make changes to keep those within about 20 feet of each other. As I mentioned, the interior tank has no power, so it is just the tank, and we'll put it inside a cabinet, leave it out in the open. It doesn't have any power run to it. The only power that's run to these systems runs to the condenser, which is located outside. A common myth that we hear, blows my mind that we still hear it in California, is that heat pumps don't work in cooler temperatures. It's a complete falsity. We've been using heat pumps. I don't live in New England anymore, but I lived in coastal New England and used heat pumps since about 2007. I'd have on my own home, I had a heat pump that would continually be covered in 4 feet of snow and still operate with no problems whatsoever. So that myth has long been dispelled. It's lingering a little bit here in California, but it's a total falsity. So tank temperature is about 130 to 176 degrees. So you don't have to be like super long, very hot showers for lots of mental clarity, no issues. So it's using a CO2 refrigerant and not the typical refrigerants that we might use in, say, a mini split heating and cooling system. So no global warming potential with these systems. Well, there's always some global warming potential with anything we do in construction, but these have, the sand and split system has the lowest global warming potential of any heat pump water heater system on the market now. The only noise is from the outdoor condenser, which like Jennifer mentioned about the integrated system, is about what you'd hear from a refrigerator. So we do try to take some measures to make sure. We've had clients who have sleep issues, and they were worried about the outdoor condenser being located, on the exterior wall where the headboard for the bed would be. So we might take a precaution to move it to a different location. Generally, we tend to put them in places, on the backside, on the exterior wall of the bathroom, put a few plants around it. I tend to think that these look just like any other mechanical system we use in homes. Some people like to cover them up with trees and bushes so that you don't see anything. So I think they're pretty cool. So.
The other potential constraint, I think especially the architects to be aware of when you're locating these heat pump water heaters, it's not really addressed in the code, but you should work with, I think, choose the brand you want and then work with the manufacturer, because heat pump, many clients want recirc pumps on their hot water heating system. It's just kind of the way they think about it. Think about putting a recirc pump. So you put this tank far away in maybe one wing of the house, and then you've got this other master bedroom, bathroom wing on another part of the house. And folks want the hot water when they want it, and they want to put a recirc pump on it. We do not recommend that you do that for heat pump water heaters. For a number of reasons, energy efficiency, just kind of water use itself, water waste. We think you should work to get your heat pump water heater or your heating water appliance, no matter what type, very close to where you need the hot water. And the heat pump water heaters do not always work with recirc pumps. Some of them, like the Sandin, just has controls on board that just won't let it work at all with the recirc pump. And others, they might work, it might affect the warranty. A couple of the warranties are very vague, and what it'll do is turn that heat pump water heater mostly into running in electric resistance mode, which defeats the purpose.
That's not going to make anybody happy.
Yeah, and so all the heat pump water heaters, they depend on having what's called a high lift. In other words, the colder the water is, the more of that heat that can be dumped into the water, and that improves the efficiency of the heat pump and the operating system. We could talk more about this at the end as well, and maybe even Kevin might have something to add at the end. So when it comes to heat pump water heater replacements, so new construction's a little different, but say you're just doing a straight out replacement, that it really comes down to, do you have natural gas available already? If the answer is yes, you can go to that NEA Tier 3 heat pump water heater list we showed you earlier and choose one of those. And if the answer is no, meaning it's already electric, then you can replace it with any of the available heat pump water heaters. The way it's written in the code, well, it's written in the code in such a way that you have to really dissect it. But the bottom line is, if you've got gas, you can use a Tier 3. If no gas, you can use anything you want, which is option D. Now, option B, when you look, for those of you who have to look at the code, option B sounds like you can use a heat pump water heater, except take a look at the very last sentence. It says the water heater shall be installed with a communications interface. What does that mean? Okay, next slide. If you go to the communications interface, what it means is, oh, you need special controls that could talk to the utility program. Oh, okay. So in other words, like the video we showed you, the Rheem has the EcoNet system. It can be in communication potentially with the utility company. The reason for doing that is so that extra grid energy can be dumped into water heaters. And those water heaters on a large enough scale could in fact add to the electric grid stability by absorbing the extra energy that's created from our extra daylight during the middle of the day when we're generating electricity from renewables. So this is still on pilot projects in California. And it's for most of us that this option really in the code isn't applicable yet, but I just wanted to point it out because it could be coming to an area near you. Okay, next. If you're going to do an addition or a new construction, basically the addition says in the code, it just says, go look at new construction. Okay, great. When you look at new construction, it sounds like you've got 5 options for your hot water heating. Well, options 1, 2, and 3 are for gas, but just as far as electric and heat pumps go, option 4 is a heat pump and option 5 is a heat pump. This part of the code was put into place assuming that the heat pump water heaters were only going to have that UEF of about 2. They would be the Tier 1 units. Option 5 is the easiest. It just says pick a Tier 3, pick one of the higher efficiency heat pump water heater units and be done, essentially. Okay, next slide. It's a little nuanced because if you're in climate zone 1 or 16, which, you know, you might be in climate zone 16 out in part of Ventura, you could use the Tier 3 heat pump water heater, but you'd also have to add 1 PV panel or show that you have a compact plumbing situation, which means your water heater is close to the plumbing fixtures. Again, this is for prescriptive. Let's say you knew you wanted to use like a Stiebel Eltron heat pump water heater. Well, it's not quite as efficient, so you'd have to up the ante a little bit by doing the compact plumbing and add drain pipe heat recovery or add a lot more PVs. And that's how you could comply prescriptively with the energy code. Some of you might be asking, what the heck is a heat is a drain pipe heat recovery system. Okay, yeah, next slide. Okay, just super simple. And again, this is for folks who are trying to read the code themselves and digest it and really wrap their brain. What are they telling me here? I just need to know about a heat, if I can use this heat pump water heater, you know? So when you see that drain pipe heat recovery, what it means is you've got this special piece of plumbing that's basically made with a drain pipe that comes from the drain of your shower or bathtub. And you've got another pipe that wraps around the outside of it, which pulls in the cold water and gets warmed up by that drain pipe that's got the hot water from your shower going down it, and it sort of preheats it before you put that back into the mixing valve for your shower. You can get energy credit for that. You can also get energy credit for using compact plumbing or using point of use distribution, which is even more restrictive, but it basically, like the little diagram, it's showing that that heat pump water heater, which is the big red circle, is within feet of the backside of the kitchen, the backside of a couple of bathrooms, and the laundry space. All of that's very close together, and that can also give you credits. You can get credits for insulating your hot water pipes. Now, some of that is mandatory for everything. Okay, I'm gonna go take you on another little sidebar here for insulation on the hot water pipes. And this is for the guys out in the field, and this is for the builders, because this is often missed, that the insulation required for your hot water pipes is a real thick rubber. It's an R7.7 per inch. Next slide. It's written like this when you look up the mandatory measures for insulating your pipe. The part I want to point out is really in bold. It's under section A, and it says, yeah, so in addition to the following pipe conditions, shall have a minimum insulation wall thickness of 1 inch or a minimum insulation R value of 7.7. Okay, so I personally think that could be worded better, because I've had people in the field argue with me that it says or, so they only buy 1 inch pipe insulation that doesn't even come close to an R7.7, and it's really cheap stuff from Home Depot. But what that means is it's like 1 inch, or in other words, a minimum insulation R value of 7.7 of the good insulation. Yeah, and someone put something in the chat too about how some of these will be updated, what the CEC is doing. So that's cool. And then the rest of the requirements for pipe insulation is the same. So when it comes to documenting your compliance or your Title 24 report, if you're doing performance method, your energy modeler is going to input the information for your heat pump water heater in there. You don't have to really worry about that. If we have anyone doing the energy modeling on here, it's going to be similar to what I'll show you for the prescriptive form if you're going to be doing it yourself. And then the CF2R, CF3R are the certificates of installation. And that's the same for all the heat pump water heater. I mean, for all the water heaters. Okay, so let's say you're going to use this particular Rheem heat pump water heater product, and you take a look at the specs, and you've got 50 gallons, nominal, 45 standard, you've got the model number, you've got your electrical size, and you've got the uniform energy factor 3.75. This is the information you need to fill out the prescriptive form. So next slide. This these prescriptive forms are interactive, which is really great. So if you're going to be doing this yourself, you can go to the energycodeace.com website and go straight to the 2019 form tools. And you're going to give your heat pump water heater a name and an ID name and say, you know, basically where is it serving or the location, and pull down on the menus and answer the questions that it's domestic hot water, it's a heat pump, you've got one of them, it's the 50-gallon size, electric, so heat pump water heater is electric, and you're going to use the uniform energy factor and put in the 3.75. And that's about all there is to it.
Simple. Keep it simple.
And then, right. And then it's when you do the installation forms that you'll have areas for the actual make and model that's being installed. So your installer will take care of that. There's a couple of, in addition to some of those rebates and programs we pointed out on the marketplace for PG&E and Southern California Edison, I wanted to point out that Southern California Edison Marketplace, it's up and running with the heat pump water heaters on there now. But I wanted to point out it's a little bit different because they're offering that rebate through the installer. And some of these units are now going to include a discount of $1,000, which is going to be really helpful in getting the price down on these units.
So thanks, Mike and Jennifer. We really appreciate you two helping us better understand heat pump water heaters and how they comply with the energy code. It's always really important and exciting to hear about. So I'm just going to provide a quick overview of our programs. And we have 3C REN currently offers 3 programs. We have Energy Code Connect, which is our codes and standards program. Building Performance Training, which is our workforce education and training program. And Home Energy Savings, which is our residential direct install program. So our Energy Code Connect program serves all building professionals, from both public and private sectors, and offers services for everyone from plans examiners and inspectors to architects and contractors. It addresses residential and non-residential applications, and we partner with many professionals across the territory, including to promote Energy Code Connect like the USGBC, ICC, and AIA. We offer, go back one slide, Mike, sorry. There's 3 distinct services associated with the Energy Code Connect program. We have our Energy Code Coach trainings, which is where this one is being offered from today, as well as our regional forums, which I talked about just a moment ago. Next slide, please. Our building performance training serves current and prospective building professionals as well. Our trainings are offered to architects, contractors, and real estate professionals. And our focus is going to expand to better serve underserved and hard to reach workers in the very near future. We offer technical skills related to building science principles and systems for high performance buildings. And that includes topics like air sealing, heat pump technologies, zero net energy building principles, passive house, and much more. And we also offer trainings on topics like soft skills, such as sales, marketing, communication techniques to grow your business. All of our classes, whether under the ECC or BPT, offer continuing education units, either from the ICC or AIA right now. And we also plan to offer certifications such as the National Association of Realtors Green Design, Green Designation, as well as Passive House, which is, I believe, coming in April, which is really exciting. Next slide, please. So if you're interested in learning more, sorry for glossing over home energy savings. We're in redesign right now, so I didn't want to get anybody's hopes up too quickly. But if you're interested, we have home energy saving. In learning more about home energy savings, please visit our website at 3cren.org/home or call 805-541-3806. For the Energy Code Coach service, you can find out more there and fill out an inquiry form if you have energy code questions at 3crun.org/codes, as well as call our hotline, which is 805-220-9991. And then for all events and trainings, you can always find it at 3crun.org/events. So if you have any, in closing, we have continuing education units available as discussed. For AIA, please contact Sean Burns there. For any ICC learning units or continuing education units, please contact me if you forgot to provide your number. We have in the next couple of days, our training slides will be provided to you, as well as a survey. If you wouldn't mind, please taking that survey for us. We actually use your input and put it to practice and develop the courses that you're looking for. So, and integrate it into existing courses. So all that feedback is really important to us. And then lastly, we have a few of our upcoming courses here tomorrow, an HRV and ERV basics course, an all electric Z&E heat pumps and electric appliances course, electrification in the 2019 energy code next week, and then passive house retrofits on the very beginning of March. And then lastly, please, if you are interested in registering, go ahead and do so for the March 11th forum and us entering the electrification frontier. Pretty exciting stuff coming up to you. So thank you again, Mike and Jennifer. I know we're a minute over, but thank you all to you who joined, and we really appreciate it.